Hello everyone, it's Alex again, and in this video we're going to be talking about conditional reasoning. Now, conditional reasoning is probably the most important concept to master on the LSAT, and this is something that tends to require weeks and weeks of practice, both with the theory and with applying it on actual LSAT questions in order to master. But today, I'm just going to talk about the very basics of it. I'm going to talk about what it is, how it's derived, and how to apply it on the LSAT. So, long story short, conditional reasoning is basically just the logic of if and then. If X, then Y. That's really what it comes down to. And it's made up of two parts. It's made up of something called the sufficient condition and of something called the necessary condition. And the sufficient condition is a statement that if it's true, it guarantees the truth of the necessary condition. So, an example, like if X, then Y, X is going to be the sufficient condition because if X is true, then it's guaranteed that Y is going to be true. On the flip side, the necessary condition is a statement that if it's false, it guarantees that the sufficient condition is also false. So again, back to our example of if X, then Y. If we know that Y is false, we also know that X is false. Because we know that if we have X, Y is guaranteed. So if there's no Y, we can't have X, simply because if we had X, then the Y would be guaranteed, and it's not there. So that's what it is. And as for where this kind of logic comes from, it comes from the logic of subsets and supersets. Now, I'm pretty sure most of you guys are pretty familiar with what a subset and what a superset is, just from your college classwork and maybe your high school classwork here at OU. But just in case you aren't, a subset is a set of things where each one of those things in that subset is also a member of a larger superset. So in this example, our subset is people under 20 who own a dog. That's the subset because we know that every person who's under 20 and owns a dog is also a member of the superset of just all the people under 20. So on the flip side, a superset is a set of stuff that contains all the instances of the subset, but can also contain other instances that are not included in the subset. For instance, people under 20 contains all the people under 20 who own a dog, but it also contains all the people under 20 who don't own a dog, say like the cat owners and the fish owners and the reptile owners out there. So another thing to note is that with the supersets and the subsets, you can have multiple supersets and subsets. So we can have a scenario where people under 20 who own a dog is a subset of all the people under 20 in general, whereas the people under 20 is a superset of the people under 20 who own a dog. But then also, the people under 20, the superset for this middle subset here, can also be a subset for another larger superset, which is just people in general. So you can have multiple subsets and supersets going on at the same time. And that's where something called chained conditional reasoning comes from, where you have multiple conditionals. Now, as for how the subsets relate to conditional reasoning itself, you guys can probably guess that if something is a subset of a superset, then being a member of that subset is sufficient to say that you're also a member of that superset. So for example, here, if we know that you're under 20 and you own a dog, that is sufficient, or in other words, it guarantees the truth that you are a person under 20. Hence, anything that lies in a subset of a superset being a member of that subset, establishing the truth that you are a member of that subset, is going to be a sufficient condition for establishing that you are a member of that superset. Now, something very important to note here is that just because you are a member of the superset, that does not guarantee the truth of you also being a member of that subset. For example, if we know that you're a person under 20, and that's all we know about you, we still don't have enough information to guarantee that you are a person under 20 who owns a dog, simply because we still leave open the possibility that you might be a person under 20 who does not own a dog, and therefore does not lie in the subset. So, being a member of the subset is sufficient to conclude that you're a member of the superset. However, it does not go backwards. Being a member of the superset is not sufficient to conclude that you're a member of the subset. Now, likewise, being a member of the superset is considered to be the necessary condition for being a member of the subset. Because as we just talked about, the necessary condition is the statement that if it's false, it guarantees the falsity of the sufficient condition. And if we were to say here that you are not a member of the superset, which is being a person under 20, if we know for sure that you are not a person under 20, then that is sufficient information to conclude that you are not a person under 20 who owns a dog. Because being a person under 20 who owns a dog is the subset. And if you're not a member of the superset, it is logically impossible to be a member of the subset. So that is where the necessary condition comes from. Now, likewise, down here, for the chain conditional statement, when we have multiple subsets and supersets, being a member of the subset down here, being a person under 20 who owns a dog, that is sufficient to conclude that you're both a person under 20 and that you're a person in general. Because this right here, being a person under 20 who owns a dog, is a subset of both this smaller superset right here and then this larger superset over here. So if we know you're a person under 20 who owns a dog, we know both that you're a person under 20 and that you're a person. Simply because we know that you are a person under 20 because you're a subset of that. And because being a person under 20 is a subset of being a person in general, we also know that you're a person. So, on the contrary, if we know that you are a person under 20, but we don't know whether or not you are a person under 20 who knows a dog, that is not sufficient information, just like up here, to conclude that you are a person under 20 who owns a dog. Simply because you could be a person under 20 who owns a cat or a lizard and doesn't also own a dog. However, being a person under 20 is still sufficient to conclude that you're a person in general. So just because it's not enough information to include the middle subset right here, is still enough information to conclude that you are a person in general. So, on the contrary, if you cross out any of the supersets, if you declare membership in any of these larger supersets to be false, you also declare membership in any of the subsets of the superset that you declare to be false, also false. So for example, if we have enough information to conclude that it's false, that you are a person under 20, we also have enough information to conclude that it's false, that you are a person under 20 who owns a dog. Likewise, yes? You guys have a meeting in here?
Yes.
Shoot.
We had this room reserved. Sorry.
Rats. Dang it. Okay. You guys sure you can't use any of the other classrooms around here?
I mean, you can try. Yeah.
Otherwise, I can move. It's no problem. Okay. Sorry about that. But anyways, if you are a person under 20, if we know that you aren't a person under 20, that's enough information to conclude that you're not a person under 20 who owns a dog, But it's not enough information to conclude that you are not a person in general, because that's still a superset. Likewise, if we know that you're not a person, we know that you're also not a person under 20, and that you're also not a person under 20 who owns a dog. Simply because this is the superset for both of those subsets. And if you declare membership in the superset to be false, you declare membership in all the subsets of that superset to also be false. So for the chain conditionals, if you declare membership in a subset to be true, you also declare membership in all of the supersets of that subset to be true. And likewise, if you declare membership in a superset to be false, you also declare membership in all the subsets of that superset to be false. Is there no other classrooms?
They're all logged or already in use.
Oh my goodness. Dang it.
Yeah.
All right. Do you guys mind if I finish this really quickly?
Yeah, sure. Go
I
ahead.
appreciate it. I'm sorry, you guys.
No, it's
Um,
okay. I'll watch your presentation.
So, as for the application of that concept on the LSAT, a lot of the prep companies tend to use this kind of diagram right here, where you have the sufficient condition right here, and then an arrow that points to the necessary condition. And the reason why they put that arrow right there is because if this is true, then it follows that this is true. So, likewise, like we described earlier over there, if you declare the necessary condition to be false, we know the sufficient condition is false. So, if A, the sufficient condition is true, then B, the necessary condition is also guaranteed to be true. But if you declare the necessary condition right here to be false by crossing it out, then that is sufficient to conclude that the sufficient condition is also false. Because like we described over here, if you declare membership in a superset to be false, you declare membership in all the subsets of that superset to also be false. And as for chain conditionals, right here, they are typically described by multiple arrows pointing to the various conditions described. So A right here would be sufficient for both B and C, which means that if A is true, B and C are guaranteed to be true. If B is true, then only C is guaranteed to be true, but we don't know whether A is true or not. Likewise, if we know that C is false, since C is the necessary condition and is the largest superset, then we also know that B and A are false. And likewise, if we know that B, the middle superset, is false, we only know that A, which is the smaller subset contained within B, to be false, but we don't know whether C is false or not, because that is the larger superset within that. So, with that being said, conditional reasoning is a pretty complicated topic, and I'm sure one video or one reading of an article is not sufficient to make you a total master of it. So I suggest going on in your own time and practicing these concepts, and hopefully over the course of weeks of intentional practice and use of resources, you can master this concept. And that's all I have for you today. Thank you.